Good morning. Today we are going to be reviewing for Unit 9. We are going to be working on the first 14 problems together, and you guys will be working on the rest of the packet that will be given to you later on by yourselves. But let's go and start with problem number 1. On problem number 1, it's asking you which of the following sets has the smallest standard deviation. And they give you 4 sets with 5 numbers on each. Now, it is best to be able to plot each of the numbers so that way we can see the standard deviation. Now remember, standard deviation is the spread out of the numbers. Are they close together or they're far apart? If they're close together, they have a small standard deviation. If they're far apart, they have a large standard deviation. So let's go start with the first one. We have 5, 8, 10, 12, and 15. And I need to see your points for each one. 11, 13, 14, 15, and 17. 7, 9, 10, 11, and 13. 12, 14, 14, 14, and 16. And we can easily locate the center for each one. For set number 1, notice that your center is 10. That'll be your mean. We can see that for set number 2, your center is 14. For set number 3, your center is 10. And for set number 4, your center is 14. Now remember, which one has the smallest standard deviation? Which ones are more piled up towards the center? So the smallest standard deviation is set number 4. Those are more piled up towards the center. So it'll be set number 4. Which one has the largest standard deviation? If it has a large standard deviation, that means that they're more spread out. So which ones are the ones that are more spread out? Set number 1. Which two sets have the same standard deviation? So which ones are spread out equally? So if you notice, the ones that are spread out equally are set number 2 and set number 3. They are spread out the same. They're shifted, but the standard deviation is exactly the same. So this will be set number 2 and set number 3. The number of carbohydrates in a 1-ounce serving of 10 breakfast cereals is listed as follows, and they give you 10 numbers. Find the range, minimum, mode, maximum, median, mean, variance, standard deviation. So let's go start with the range. To be able to find the range, you have to take your largest number minus your smallest one. So let's go and list them in order first. Smallest number is 48, 45, then 48. We have 48, we have 50, we have 51, 52, 55, 59, 60, and 60. And let me confirm that I have 10. 2, 4, 6, 8, 10. To be able to find the range, I'm going to take my largest number minus the smallest one. So it'll be 60 minus 45 gives me 15. Make sure that you show me the work. Minimum. To find the minimum is the lowest number, which is 45. The maximum is the largest number, which is 60. Mode. To be able to find the mode is the one that repeats the most. So in this case, 48 repeats twice, and 60 repeats twice. So therefore, both of them are the mode. 48 and 60. Median is the one in the middle. So let's have 3 here and 3 here, 1 and 1. So I have two numbers in the middle. So therefore, in order to be able to find the median, I'm going to add them both and divide by 2. And you're able to use a calculator. So 51 plus 52 divided by 2 will be 51.5. So your median will be 51.5. If there's only one number in the middle, then that's it. But if you have two, you add them up and divide by 2. Just take the average of them both. The mean, you're going to add up all the numbers and divide by how many numbers we have, which is 10. So let's go and add them up. 45 plus 48 plus 48 plus 50 plus 51 plus 52 plus 55 plus 59 plus 60 plus 60. And divide by 10. That gives you 52.8. That will be 52.8. Now, to be able to find the variance, we are going to use our mean and subtract it. Now, to be able to use our mean, we're going to round it up for purposes. We are going to round it up to 53. Your actual mean is 52.8, but to be able to find the variance, we're just going to round it up to 53. And you can either do the chart that we did on the notes, or we can just do it as the equation says. We are going to take each number and we're going to the difference between each number and the mean and square it. So let's go and start. 45 minus 53, it's negative 8, but because we're going to square, we're just going to say it's 8 squared. 48 minus 53 is 5 squared. 48 minus 53 is 5 squared. 50 minus 53 is 3 squared, and so on. So go and finish it up and see what you get. So everybody's doing the next one. 51 minus 53 will be 2 squared. 52 minus 53 will be 1 squared. 53 minus 53 will be 2 squared. 59 minus 53 will be 6 squared. 60 minus 57 is 7 squared. 60 minus 53 is 7 squared. So you take the difference and square each number, and you're going to divide by how many numbers we have, which are 10. And since we're able to use a calculator, we can just type everything as is on the calculator. And just start typing in 8, and I'm just going to use my square, plus 5, and I'm going to use my square, plus 5 square, plus 3 square. And I'm going to continue on all the way through. Plus 2 square, plus 1 square, plus 2 square, plus 6 square, plus 7 square, plus 7 square. And that's going to be equal to 266. And I'm going to divide it by 10. I'm just going to divide by 10. So therefore my variance is 26.6. Your standard deviation will be just the square root of your variance. So you're going to take your variance and you're going to take the square root of it. So therefore I'll be the square root of your answer, or 26.6, and I'll be 5.15 or 5.16. Let's go just leave it as 5.2. We're going to round it up to 5.2. So remember, to be able to find your standard deviation, you have to find your variance by going through this process, and then once you find your variance, you just take the square root, and that'll be your standard deviation. So let's continue to problem number 5. if you were going to multiply by 4 to each number in set number 1, which of the following will result? And we need to select two answers. Now remember that if you add or subtract, then your mean gets added, but your standard deviation stays the same. That's because whenever you add, your points just get shifted, but they don't get spread out more. Remember, standard deviation is the spread. Whenever you add 4, if you were going to be add 4, 5, or any number, they just get shifted, but the spread doesn't change. But whenever you multiply, then your mean gets multiplied, and your standard deviation gets multiplied as well. So whenever you multiply, they expand. They still shift, but they also expand, and therefore your standard deviation also changes. So let's go to the answers. A, the standard deviation will be multiplied by 4. So if you multiply, your standard deviation will be multiplied by 4, which is correct. Letter B, the standard deviation will not change. No, if you multiply, it will change. The standard deviation will increase by 4. No, if you multiply, it's going to be multiplied by 4. The mean will be multiplied by 4. So whenever you multiply, your mean will always also change. Remember, your mean is going to change either way. If you multiply, it's going to multiply. If you add, you're going to add. Standard deviation is the one that's different. The mean will not change. False. The mean will increase by 4. No. If you multiply, it's going to be multiplied. So your answers are A and D. Problem number 6. A student's 4 test scores were 78, 65, 67, and 72. What score will be needed on the 5th test to obtain a mean of 71? So we want the mean to be 71. So you need to think, okay, how do I find the mean? To find the mean, I need to add all 5 numbers. So I need to be able to look for the 5th number, that whenever I divide them by 5, whenever I add them and divide by 5 gives me 71. So let's see. Let's try the first one. So we're just going to test and see. And since we're able to use a calculator, it makes it much easier. I'm going to use my fraction bar to make it a little faster. So it'll be 78 plus 65 plus 67 plus 72 plus 70.5, and I'm going to divide it by 5. And if that one's correct, that should give me 71. And in this case, it gives me 70.5. So that's incorrect. I'm going to try 73. So instead of retyping, I'm just going to go back, up, and delete, and change it to 73. If that's correct, then my average should be 71. And it is. So therefore, your answer is letter B. And if not, you can just continue testing the rest of them. Just to confirm, the next one is 71. Your average is 70.6. That's incorrect. We're looking for 71. The next one is 69. And your average is 70.2. So no, we were looking for 71. So in the work that you need to show me here is 78 plus 65 plus 67 plus 72 plus the 73 divided by 5, and that is equal to 71. Remember that you need to show me work on each problem. Problem number 7. A football team has a mean height of 75 inches and a standard deviation of 4 inches. Jack is 82 inches tall. How many standard deviations is he above or below the mean? Now remember that whenever they give you the mean, it is best to be able to label it. They place the z values underneath, so let's go and place our actual values, 75 right above. So that's 75. And they tell you that the standard deviation is 4. So therefore, if that's 75, the next one will be 79. And the next one will be 83. And the next one will be plus 4, 87. Minus 4 will be 71. Minus 4 will be 67. And minus 4 will be 63. Now, Jack is 82 inches tall. How many standard deviations is he above or below the mean? So if it's 82, therefore Jack is 79, 80, 81, 82. So right around here. That's 82 for Jack. So how many standard deviations is he above the mean? So he's about 1.6, 7, 8, 9. But we're looking for the exact value. So therefore we need to use our z formula. You must memorize your z formula. Z is equal to x minus your mean divided by your standard deviation. So x is Jack's height, which is 82, minus your mean, which is 75, divided by your standard deviation, which is 4. 82 minus 75 will be 7 divided by 4. And you are able to use a calculator, so therefore we can do 7 divided by 4, and that will give me 1.75. So therefore you just need to make sure you write it down. Jack is 1.75 standard deviation above or below? Above the mean. And this will be your answer. Now remember that it's a great deal to be able to graph it, especially if one graph is given to you, so you can answer the question, and whenever you answer it, it kind of matches your answer. The diameters of bolts produced by a certain machine are normally distributed with a mean of 0.30 inches and a standard deviation of 0.03 inches. What proportion of bolts will have a diameter greater than 0.297 inches? So remember that whenever they're asking you for a proportion, you're looking for a percentage. And because you probably will not get any of the standard deviations, you're going to have to use your z formula, so you can look up your z score in your chart. So let's go and label the chart since it's given to us. They tell us that the mean is 0.3 or 0.3. So that's your mean, 0.30. And a standard deviation of 0.03. So therefore this will be plus 0.03 will be 0.33 plus 0.03 or 0.36, 0.39. To the left will be 0.27, 0.24, and 0.21. What proportion of the bolts will have a diameter greater than 0.297? So let me go ahead and add 0 so I can easily identify where it's located, since that one has 3 decimal places. So therefore 0.297 should be right below the 300, the 0.300. So therefore that should be located there. And what proportion will be greater than? So therefore greater, I must shade this section to the right. And we know that because if it was from 0 all the way to the right, that'll be 50%. So I know it has to be bigger than 50%. So I know C and D are not the answers. But let me go ahead and use my formula. My formula is Z is equal to X minus your mean divided by your standard deviation. X is the one that we're looking for, so it'll be 0.297 minus your mean, which is 0.30, divided by your standard deviation, which is 0.03. Just be careful with your decimals. And I'm now going to type that into the calculator. I'm going to use my fraction bar, and that will give me 0.297 minus 0.30 divided by 0.03. Careful with the decimal, make sure that you have everything correct. And that's going to give you a Z value. So your Z value is negative 0.1. And we're going to look up your Z value. This is your Z value. We're going to look it up on your chart to get your percentage. So all of you guys have your chart, and that is negative. So I'm going to use my negative side, and I'm looking for 0.1, negative 0.1. And there's no decimal, so there's a 0 right afterwards. So that'll be 46.92. That'll be your percentage, will be 46.92. 46.02. Now remember that this gives you the area to the left. I'm looking for the area to the right. So it'll be 100% minus 46.02%, which is equal to 53.98%. And you can use your calculator to be able to calculate, so therefore your answer is letter B. For next question. Now let's continue to the back side. Find the area of the shaded region, and notice that the shaded part of the graph. The graph depicts the standard normal distribution, so it's a normal distribution, with a mean of 120 and the standard deviation of 6. So therefore the standard deviation, the mean is 120, and they already labeled 120 for you. And the standard deviation is 6. So if I add 6, that'll be 126. Add 6 is 132. If I add 6 more, it's 138. If you subtract 6, it's 114. Subtract 6 is 108. And subtract 6 is 102. Now, we want to find the area that's shaded. And notice that the numbers that they give you doesn't fall on the Z values. So this will be 0, negative 1, negative 2, negative 3. If it did fall on the negative 1, then we can use our 68, 95, and 99%, but it doesn't. So therefore, we're going to have to find the Z values for each one. Then look up your percentage in your chart and subtract them. So we're going to have to find the Z value for the first one and the Z value for the second one. Now remember, your Z value, your Z formula is X minus your mean divided by your standard deviation. X for the first one will be 103.92 minus your mean, which is 120, divided by your standard deviation, which is 6. And now I'm going to use my calculator to type that in. And you guys will be able to use your calculator for the test. So I'll use my fraction bar. It will be 103.92 minus 120. And I'm going to divide by 6. Negative 2.16. Now I'm going to use, this is my Z value. and I need to be able to find my percentage. So now I'm going to use my chart. Negative 2.68, negative 2.6, and I'm going to go over to the number 8. So my value is 0.037. If I change it to a decimal, I'll move my decimal to the right too, so it'll be 0.37%. So the percentage will be 0.37%. And sometimes you will be getting very tiny decimals. Now let's go and do the second z value using your second x. So it'll be 116.16 minus 120 divided by 6. So this is your x minus your mean divided by your standard deviation. Let me just go back, and your x now is 116.16. Change to a decimal, negative 0.64. This is your z value, and I'm going to look up the percentage on my chart. Negative 0.6, and then 4 will be 2611. And I'm going to take my biggest percentage minus the smaller one, so that will give me the area that I'm looking for. 26.11 minus 0.37, which is 25.74. So once you subtract 26.11 minus 0.37, your answer is 25.74%. And notice that your answers are not in percentage, but we know that that'll be letter D. Now, let's go over to question number 2. The height of an adult woman in the United States is normally distributed with a mean of 60. So the mean is 60 inches. So let's go ahead and label it. So that's your mean, 60 inches. And the standard deviation of 4 inches. So notice that they will replace your x values. So every 4 will be standard deviation. So 1, 2, 3, 4 at 64 will be 1. 1, 2, 3, 4, that'll be 2, and there's no space for the third. To the left, 1, 2, 3, 4, that'll be negative 1. 1, 2, 3, 4, that'll be negative 2. So kind of working backwards. And draw a line at the value that approximates the height of which 45% of the women are shorter and 55% of the women are taller. So this is what we did last time. And remember that whenever we're using your chart, these are the percentages for the people that are slower than you or shorter than you. So therefore, we're going to be looking for the 45% that are shorter or the 55% that are taller. We are going to use the 45%. And we're going to look for the z value so we can place the line. So percentage is 45, 45, 45. I'm looking for 45. I'm going to turn the page over. 45%, 45%, 47, 48, 44, 44, 45. So it has to be between 48 and 83 and 45 and 22. So to get to 45, you need 17, and to get to 45, you need 22. So this one will be closer to 45. So it'll be negative 0.13. So your z value is negative 0.13. And from there we can place your bar. Negative 0.1, so it will be right after. So somewhere in here. That'll be your x value. Remember, negative will be to the left, and this is negative 0.1, just slightly before the 60. Now it says find the height of the 45th percentile. So now that you have your z value, we can find your x value. So we're going to use the formula. Z is equal to x minus your mean divided by the standard deviation. So now we have your z value to be negative 0.13 equal to your x is what you're looking for, minus your mean, which is 60, divided by your standard deviation, which is 4. Now I need to solve for x. So I'm going to multiply both sides by 4. And I'm just going to use my calculator. 4 multiplied by negative 0.13. That gives me 0.52 is equal to x minus 60. I'm going to add 60 on both sides. So therefore x is equal to 60.52. That is the height that will divide the 45% that will be shorter than this height. So let's continue to problem number 11. Which measure of center will be more appropriate to represent the data? The mean or the median? Since this is skewed towards the right, we have to use the median, since there are two reasons. The data is skewed to the left, or the histogram in this case is skewed right, excuse me. But there's also an outlier, and there is a median. So if it's skewed left or right, or if there's an outlier, then we have to use the median. Problem number 12. Which measure of center will be more appropriate to represent the data? The mean or the median? If you notice, this graph is symmetric, symmetric, therefore we have to use the mean. So I know it's not C or D. And is it because there's an outlier or because the distribution is symmetric? So therefore your answer is letter B. Problem number 13. Evaluate each of the following and select the ones that are equal to 9. So I want it to be equal to 9. And this is the one that you guys are having difficulty on your tests. And especially when you're simplifying letter A. So letter A, whenever you have different bases, I know that I can make them the same base. I can make the 9 as a 3. So let me rewrite. I'm going to rewrite the first one. 3 to the 4/3 multiply. But instead of the 9, I know that 9 is equal to 3 squared. So therefore, 9 to the 1/3, I can rewrite it as 3. And it will be 2. The denominator stays the same. Or you can just multiply the exponent. There's several ways of thinking about this. But in this case, the 9, I'm going to replace it with 3 squared. So instead of 1/3, it will be 2/3. And this will be 3. I'm going to add, so it gives me 6/3. I'm going to simplify, so it gives me 3 squared, which is 9. So that one's fine. Now remember that you can rewrite exponents that are fractions as radical. 27 goes inside. And 3 is the root. And that'll be to the second power. So I can rewrite this. The cube root of 27 is 3. To the second power will be 9. So that one's also correct. Letter C. This is the one that you guys have having a challenge simplifying. 3, I want to make them the same base. So I want to make the 27 a 3. And I know that 27 is equal to 3 to the 3rd power. So therefore, instead of 27, I'm going to replace it with a 3. And instead of 27 to the 1/2, it will be 3 halves. It will be 3/2. So your 1/2 becomes 3 halves. Multiply by 3 halves. And now, since they have the same base, I can go and add my exponents. So 3 halves plus 3 halves will give me 6 halves. 6 divided by 2 is 3, which is 27. So that one's wrong. Now remember that whenever you have an exponent as a fraction, we can rewrite it as a radical. The 2 is your root, and to the first power. Square of 9 is 3, to the first power is 3. So that one's wrong. And there are times that you can simplify your fraction. Since this is a square root, I can rewrite it as a exponent. So this will be 4 halves. Remember, this becomes your denominator. And I can simplify as 3 squared, which is 9. So your answer is also E. So on this one, you have to be very careful. Sometimes it's better to be able to rewrite it as a radical to simplify it. Sometimes, if it's a radical, it's easier to simplify by placing it as an exponent. So you have to kind of think of both ways. And the last one that we are working together is number 14. The rest of the packet, you guys will be doing it by yourselves or in groups. The following table shows the students' scores for 2 subjects, biology and history. The mean score for the test, so they give you the mean score, and the standard deviation. Now remember, the standard deviation will tell how spread out the numbers are. And we are assuming that both distributions are normal. They're asking you to find the percentile. But before I find the percentile, I need to be able to find my z-value for each one. And then I can look up the percentile on your chart. So I have to find, for biology, I'm going to have to find my z-value. And for history, I'm going to find my z-value. And once I have my z-value, then I can look at my percentage in the chart. Remember, your formula is your x, which is 80, minus your mean, which is 75, divided by your standard deviation, which is 5. And 80 minus 75 is 5, divided by 5 gives me 1. And I'm going to look up 1.0, that is my z-value, and I'm going to look it up in my chart to see what percentage that is. Negative and 1, positive 1.0, which is 84.33. So 84.33. In your history class, you also received a 80 in your score, but the average, the mean was much higher, and the standard deviation was also 5. So 80 minus 92 is negative 12, divided by 5. I'm going to use my calculator to calculate this. So negative 12. Make sure that you place your negative. So whenever you type the same, make sure you use your negative and not your minus, divided by 5. And that gives me a value of negative 2.4. And I'm going to look at, this is your z-value. And I want a percentage, so negative 2.4, and not decimal afterwards, so 0.0082. I'll move the decimal to the right 2 times, so it'll be 0.82%. And remember that your percentile will tell you that percentage of students that score lower than you. So if you notice for biology, even though you got an 80%, you were among the top 84%. So your score was pretty good compared to everybody else. And in history, even though you scored 80%, you score among the lowest 1%, because most of the students got an average score of 95, 92. So most of the students received A's or above. So go ahead, you'll be given the rest of the packet, questions number 15 and on, and that will be due next time I see you. Have a great day, and please behave. Thank you.